Let's prepare on water treatment methods. Water treatment methods. So there are several methods for the treatment of the water. So they are listed here. Screening, plain sedimentation, sedimentation with coagulation, filtration, disinfection, aeration, softening and other treatment method also. So the first we'll be seeing the screening. It is the basic and simple method of treatment of the water. Okay, so it is just like a filter paper or cloth we are using for filtration of the water. So it is similar to that only. So if the openings in the screens are more, means it is a core screen and the size varies from 2.5 to 5 centimeter. If it is very fine, it is called as fine screen, and it is even less than 6 mm in size. So based on the type of screen, the particles recovered from the screen also differs. So the angle that is the screen is set up is nearly 45 to 60 degrees, so that the coverage of the area will be more, so that more amount of water can be screened. And the velocity of the water that has to be passed in the screen should be 0.8 to 1 meter per second only. So it is a very slower motion only. The next is sedimentation. So here the settlement of the particles present in the water depends on various parameters. So we will see that first. So the shape of the particle, size and the temperature of the water. So if these three are very larger, means the settlement will be so quick. But the viscosity and velocity should be lower for the settlement to be happen. So these both are inversely proportional to the settlement. So there are two laws to be studied in the sedimentation. The first one is Stokes' law and the next is Newton's law. So first in the Stokes' law, it is given the velocity is equal to g d square by 18 nu g minus 1. Here capital G is specific gravity, d is the diameter of the particle and nu is the kinematic viscosity. So this formula is valid only if d is less than 0.1 mm. So the Vs is also given in another formula with respect to the coefficient of drag, that is Cd. So it is given as 4Gd into G minus 1 by 3 Cd. So the Cd and Reynolds number is related here. So first let us see what is Reynolds number. Reynolds number is equal to Vd by nu. So it is also written as rho Vd by mu. So here mu is the dynamic viscosity. So Thomas Camp has given a graph with respect to this Cd and the Reynolds number. So when you are making that graph, you can get the values of Cd with respect to the Re values. There are three ranges are taken from this graph and given like this. Cd is equal to 0.4 for Re is greater than 10 power 4. Cd is equal to 24 by Re for Re less than 0.5. Cd is equal to 24 by Re plus 3 by root Re plus 0.34 for Re from the range 0.5 to 10 power 4. So these Cd value can be directly taken with respect to the Re range, and from that you can substitute this Cd value in the previous formula to find the velocity of the settling particle. The next is Newton's law. So here the Newton's law gives the formula settling velocity is equal to 1.8 root Gd into G minus 1. So this formula is suitable for the diameter of the particle greater than 1 mm. So between 1 mm and 0.1 mm another formula is given by the Newton. So it is 418 into G minus 1 into D into 3T by 70 by 100. Here T is the temperature of the particle. And the next we will see the overflow rate. It is represented as V0 and it is the discharge by surface area. So it is nearly equal to the depth by time, which is the velocity of the water also. So the flow through rate of the water and the overflow rate of the water will be same in the case of the sedimentation tanks. So the settling velocity should be always greater than the horizontal velocity of the water. Then only the settling will be happening at a faster rate. So it is related in another formula that Vs should be always greater than or equal to h by capital H into V0. Here the small h is the height of the any particle that we are considering and the capital H is the total height of the sedimentation tank. It means that at any point of time the Vs should be always greater than the V0, then only the 100% settling will be happening there. And the percentage of settling is given as Vs by V naught into 100. So when Vs is nearly more means the settling will be nearly 100%. And the overflow rate range should be 12 to 18 meter cube per day per meter square for the plain sedimentation tank and 24 to 30 meter cube per day per meter square for the sedimentation with coagulation tank. And the next is detention period. So the detention period is given by the volume by discharge, that is BLH for the rectangular tank by Q, and for circular tank it is given as D square into 0.011 D plus 0.785 H by Q. So the detention time is the time of that water that is kept in a sedimentation tank for the settling of the particles. So it is 4 to 8 hours for the plain sedimentation tank, and for sedimentation with coagulation tank it is only 2 to 4 hours. So it is speeder than the previous one. The next is horizontal flow velocity. So it should be maintained in the range of 0.15 to 0.9 meter per minute. Generally they will be taking 0.3 as the value. The displacement efficiency. So what is this displacement efficiency is the flow through period of the water which is actually happening in the tank will not be equal to the detention time which we have calculated theoretically. So there will be some differences. This is because of the short circuiting of the water. So when the water enters into the tank, it may hit to any wall and it may go out suddenly without completing its full detention period. So that some change in the detention period will be happening. So that is the original time taken by the water. We will represent it as flow through period. So the ratio of this flow through period by the detention time period is named as displacement efficiency. And the next is score velocity. The score velocity is nothing but it is the velocity that lifts up the particles or just washes away the particles that has been settled. So that the flow velocity of the water in a sedimentation tank should be always lesser than this score velocity to prevent the washing of the particles. Here the formula is given as root 8 beta by f dash into g minus 1, where f dash is the friction factor and g is the specific gravity and d is the diameter of the particle. The next is sedimentation with coagulation. So it is needed when the turbidity is greater than 30 to 50 milligram per liter only. Otherwise you can go for the normal plain sedimentation itself. So here various types of coagulants are used. So we will see one by one. First is alum. It is aluminium sulfate and you can see the chemical formula for that, because in the objective type questions they will be giving the chemical formula and we have to find the correct one. So it is Al2SO4 thrice dot 18H2O, and you should be clear with the process that is happening with the alum also, because they may ask the end products of the reaction in the objective type question. So that you should be clear with that also. So when alum reacts with the calcium hydroxide in the water, it gives calcium sulfate, aluminium hydroxide and carbon dioxide. So the optimum pH that has to be maintained for this process should be 6.5 to 8.3. 1 milligram per liter of alum will be giving 0.5 milligram per liter of alkalinity. Normally in a water there should be 5 to 10 milligram per liter of alkalinity maintained even after the treatment. So based on that, the alum has to be added in an extra amount. And the next is copperas. Copperas is ferrous sulfate. So when ferrous sulfate reacts with water, it gives calcium sulfate, ferric hydroxide and water. So it is a very cheaper and the pH has to be maintained above 8.4. It is very high and therefore it is not used for colored waters also. And the third one is chlorinated copperas. It is nothing but the chlorine is added with the copperas to produce ferric chloride and ferric sulfate. So these ferric chloride and ferric sulfate is only termed as the chlorinated copperas. So this is used for colored water also, and it can be used in the very low pH of the water also. Even the pH is less than 3.5 also, we can use this chlorinated copperas. And the next is sodium aluminate. So it is Na2Al2O4. So when it is reacted with water and calcium hydroxide, it gives CaL2O4 and sodium carbonate, carbon dioxide and water. And the flocculation process is also related with this sedimentation one. So when the coagulant is added in the sedimentation tank, flocks will be happening. And so the flocculation has to be done here so that the flock particles will be settling down quickly. So the velocity gradient that has to be maintained in the flocculation tank should be root P by mu V. P is the power, mu is the dynamic viscosity, and V is the volume of water. The paddles that is provided in the flocculation tank should rotate in an 2 to 3 rpm only, so that it will be a very slow rotation, and this only allows the flock particles to settle down quickly. The detention time of this flocculation tank is just 20 to 60 minutes, and the velocity gradient should be maintained in the range of 20 to 80 per second, and the clear distance between the paddles and the walls, either in the side or in the bottom, that is the floor, it has to be maintained as 15 to 30 centimeter. Thank you, and keep watching for the next lecture on the continuation of this water treatment methods.